It says our galaxy could be evaporating as dead stars flee the Milky Way. Space, October 4th, 2022. By Brian Koberlin, University. So, it says the Milky Way's underworld is shaped like an elliptical galaxy. It says everything dies in the end, even the brightest stars. In fact, the brightest stars are the ones that live the shortest lives, right? Because, let me say it this way, in a superdeterministic universe where the game is played incorrectly, the game of life is played incorrectly, everything does die in the end. Because that means you did nothing, you didn't even play the game. Because you didn't even play it correctly. You know, only winning move is not to play and you decide not to play, type of thing. In a supra-deterministic universe, you have your free will. It's basically what optimistic nihilism is. You do something with your life in the universe, and you don't let it evaporate away. Anyways, just a distinction I thought I'd make. So, it says they consume all the hydrogen they have within a few million years, then explode as brilliant supernovae. Right, you know, assuming you don't take supra-space or supra-determinism into account and alter the lifespans of those stars using magnetism, gravitational magnetism, or whatever, understanding gravitons. Anyways, a whole different thing there. But we'll go on this line of reasoning that we're never going to do anything ever about it. Okay, it says they consume all the hydrogen, blah blah, explode as brilliant supernova. Their core remains collapse into a neutron star or black hole. These small dark objects litter our galaxy like a cosmic graveyard. Okay. So what I was telling you is that think of how a neutron star. Think of how a pulsar is. Think of a neutron star. These are stars. Now think of a stellar black hole, right? Well, that's a star mass black hole. But even that, what's one stellar mass? That's the mass of the sun, right? So one stellar mass black hole would be a tiny thing. It would be so small. It would be baby. So I'm saying, well, if you say one stellar mass, I'm saying if you apply one solar mass, my bad. One solar mass of our star to a black hole, its shape, its size in space-time would be tiny. So if you start adding solar masses, then you start getting somewhere. Then you start getting a big black hole, right? I'm saying, now scale that up and make a planet-sized black hole. Yeah, you ever read that book about the little beings living on a neutron star? I told you all you had to do is harness thermal quench to understand how to use that in geometric space-time to edit your. Anyways, you can basically shrink your size, go down, and live on a neutron star as if it were a planet. Anyways, different topic for a different day. You can keep your size in this Euclidean geometric space-time. Imagine that we ourselves are made of those tiny black holes. Try to construct a black hole human. Well, it would probably feel the weight of time dilation itself as it moved around, right? Boom, boom. It would feel weight if it was made of these gravitons, right? These gravity holes, these gravity planets. Well, we live on a gravity planet, right? So now imagine a black hole but its effects were so weak that it didn't spaghettify us. Its effects were so weak that we could exist and breathe inside of it, right? Its effects were so weak, its gravitational effects were so weak that it balanced out to the size of 1g, the gravitational constant. Now we're starting to get somewhere. Are we? Now we're starting to say, wait, that describes our reality a little bit, doesn't it? That this is essentially, like I said, go look at Isaac A. Arthur's video, Black Hole Earth. That's what I'm saying. If you were to scale up these Kugelblitz, I don't know if any of you heard the video, but there's a video I was watching. Don't know how long back. I don't care. That's not the point. It said, in the beginning of the universe, assuming the Big Bang model is correct, which, spoiler alert, it is, then there should have been a ton of Kugelblitz black holes, micro black holes everywhere throughout the universe. Where are they? And I'm like, hey guys, you are the Kugelblitz black holes, you just don't know it. That's why we feel mass at all. Because I said, basically, the universe keeps stacking complexity and stacking complexity and stacking complexity. It started in a lower dimension. Okay? I said, you have to understand how non-Euclidean geometry gave way to Euclidean geometric spacetime. Everything keeps stacking complexity. I said, eventually we gained consciousness because we stacked enough complexity that we just became self-aware. You know what I'm saying? It only keeps increasing from there. Now classical Newtonian physics, computer AI, can now have consciousness too. In a much shorter time than we even took to get consciousness. And I'm saying that's what happens with generations and iterations. You can't stop this process if you started it, because the universe takes care of it for you. People often said, they're like, oh, humans are like this virus upon the earth. And I'm like, okay, well, what do viruses do? They latch onto the host to maintain homeostasis of their own. They can't live without the host. So, saying that humans are viruses in that sense is correct. Humans cannot live without the earth, in a sense. But we can harness this relationship to get us past this stage, okay? Where I'm saying, okay, the earth, we can decouple ourselves from the earth if we must. We no longer have to be tied to the earth. So we no longer have to have those considerations. But, just my suggestion, I think we should thank the earth for hosting us for so long. Because it's not like we're going to leave the earth. Why would you leave it? That's what I'm saying. Just take care of the earth now. It's so easy. We have the technology to do it. Literally, we do. Because at least I understand particle physics. Because just look at string theory. Okay, whatever. I'm not going to go there. I'm going to read the rest of this. Basically, I just don't like repeating myself a dozen times. Over and over and over. A couple dozen times. A couple 100 dozen times. It's just not. At some point, I'm just like, go back. Look at your data set. Look at the data set I've been creating. Look at my own data. Deduce what I'm saying. And review it. Okay. This is both neutron stars and stellar black holes are difficult to detect. Neutron stars are only about 15 kilometers across. That's what I'm saying. They're if there are beings on them, they're really tiny, is what I'm telling you. because we ourselves are really tiny compared to Earth. That's what I'm saying. To them, you have to imagine that they feel normal walking around their planet. And they probably don't think their minds are probably thinking so fast and experiencing subjective reality so fast, special relativity so fast from their point of view, that they're not aware that they're on a neutron star whatsoever. And they're probably not aware that their completely normal gravity is actually a symptom of them being like really tiny beings on a neutron star. That's what I'm saying. They don't know this. I'm saying we're basically in the same situation here, where we're in a universe where someone can see us, but we can't see outside. Only if we use this seismic technology that we deduced for Earth, penetrating the Earth with like these waves, basically, kind of like how you do sonar. I'm saying only by doing that can we project outside of our universe by simulating outside of our universe to understand what's out there. So basically, you can use technology to simulate your way out of the universe and open up portals if you must. Because now we can do so. We can create new particles. Hello. We're literally creating reality. I'm saying so. Yeah, neutron star would be the size of Manhattan. I'm like, there could be tiny beings that are Manhattans, okay? And they don't know they're on a neutron star. That's what I'm saying. And from their point of view, our Manhattan would be huge. Because that's like their whole planet. They don't think they're a star. That's what I'm saying. That's how you had to start thinking of this. So this is black hole. Right next to it, right? That's what if you were to condense a stellar mass black hole, it would be that size compared to Manhattan. That's what I'm saying. You could have people on a black hole. You could have basically a Manhattan planet. But you could have a simulation of Earth itself in a black hole, where there is a Manhattan in the black hole, but it's directly translated down to the exact size it would be. It's transmogrified. It's translated. That's why I said using this technology you can understand how to make a universal translator. Especially of revealing intent too, once you understand how to think emotionally. Okay, in mathematics. Okay. So stellar black holes are even smaller and don't give off much light of their own. That's what I'm saying. It doesn't give off light because we can't perceive that. I'm saying look back towards X-rays. Think of X-ray stars. Think of LED stars. Think of these exotic type of stars that you could only create. And then you can start simulating these other realities. Okay. It says some appear as microquasars. That's what I'm saying. What's a macroquasar? Well, that's what we would see if we were able to go to one in real time. Like actually experience it in front of our own flesh, blood, and eyeballs. But a microquasar would be like from some simulated universe or like some super small. That's what I'm saying. Super small, super big, it doesn't matter. It's the same thing. It's micro and macro. It exists on a spectrum. I mean, you probably thought microwaves were not such an advanced technology, but they are. Just like radio waves are an advanced technology. More advanced than people give it credit for. And that's what I said. You can start using simulations to understand how you may be radio blind because you don't understand magnetism of radio waves yet. Radiomagnetism, okay? To understand how to see radiolight. You can visualize radiolight just the same way you can visualize thermal, radiation with thermal goggles, I guess. So anyways, consume the mass of a companion star, but most would only be seen when they pass between us and more distant stars, so they could be detected by microlensing. Okay, what about macro lensing? Okay, what about gravitational lensing? I guess that's what macro, or it's, you know what I'm saying? There's always, okay, if you do this, well, what about this? If you do this, well, what about this? There's always another. I said there's always there's always a mirrored reality to you. And I'm saying mirrored isn't necessarily negative. It just means mirrored. Because you can mirror those two things on another axis. That's why I'm saying you can think in quadrants now. And basically you can move those quadrant graphs around in your mind in a 3D sense. Think of a 2D plane, and then think of a 2D plane that bisects that, and one that bisects that. Basically, you keep bisecting it, okay? That's why I said humans are bilateral beings. Well, until you got us horizontally, but that's what I'm saying. If you evolved like a starfish, you'd probably think in 5 dimensions, right? If you evolved like an octopus, you'd probably think in 8s. Or a squid. How many do squid have? I don't even know. Does it matter? Have I made my point yet? We evolved in such a symmetrical way that you have to think of the supersymmetry of the universe. And then you know what I said to supersymmetry? Superdeterminism, measuring the superdeterminism of the universe, how that may seem nihilistic. I said, let's put an optimistic spin on that. What do you get? Supra-determinism. There. By basically considering that you may have not had free will. You willed free will into existence. Congratulations. That's why I started telling people, imagine it this way. Our brains are Kugelblitz, black holes, and shell worlds or something. And those are soft logic barriers, because you can never get rid of information. There's no information paradox. So our brains might as well be like Boltzmann brains, right? And we might as well have our brains quantumly entangled in some other space-time dimension. And we're just simply quantum entangling back towards Earth in an anti-radio wave function, right? It's the noise, it's the decoherence, it's the incoherence. It's the anti-radio waves. Well, why do radio waves even deteriorate? Well, because there's some resistance there, right? Oh, it's all the particles in the way, right? It's all the gravity waves, it's all this other stuff in the way, right? That's what I'm saying. So, what you have to think is, I guess it's frequency modulation, okay? You have to be like, why are our radio waves so leaky? How about we narrow the bandwidth? I'm saying that's what you're doing. You're basically narrowing the wavelengths, okay? You're deducing these wavelengths. You're using wave understanding, okay? You're using sonar. You're using the sonar of radial technology, okay? Radio. Which is why I said those fireside chats that they used to do were like the best thing that they had done. Because you could actually, like in real time, actually try to attempt to inform the nation. But now we do it using satellites, but now we have to do it using, I guess, whatever's next, like quantum internet, quantum communications or something, right? Because using quantum physics, you can understand the tachyon particle and the anti-tachyon particle, which is much faster than the speed of light, by the way. The speed of light is kind of slow in comparison. That's what I'm telling you. Because I'm like, the only reason photons have resistance at all is because of the advent of gravity. That's what I'm saying. Who the hell invented gravity? Stop inventing shit. No, I'm just messing with y'all. Yeah, basically gravity slows it down. And what is gravity? Well, gravity doesn't actually exist. It's just the illusion of all these particles in the way of photons. That's all it was. It was the magnetism. It was the stretch and the pull of the universe. That's what created the illusion of gravity. And I'm saying, you know what? This illusion of gravity, we can put into a particle. Call that a graviton. You know how I did this? That's what I said. You had to think. Remember the PBS Spacetime video I commentated on that had the X drawn? I said that is a slice of life. You ever heard of slice of life animes? Basically, if you play the game the way you want to play it, basically, and the way I play it is the 101%, the Garden of Eden playthrough, then you basically can figure out how to navigate the wave function of the universe. Because if you listen to John Archibald Wheeler, the theoretical physicist, he's like, the only uncomfortable thing about this is he's like, we're all like bits of data or whatever, information trying to figure itself out. There's a video on PBS Spacetime about it. We're just trying to, I don't know, something. Basically, I said, well, what I'm saying, Eden, is I'm saying you can deduce existence and non-existence into a state of 1 and 0. So we're just bits of information, exactly like John Archibald Wheeler had said. Which is exactly why on that PBS Spacetime video, they said, if this all sounds a little wishy-washy, and like, you know, basically hinting that if it sounds magical or mystical, it's because he didn't finish it. He died in 2008 AD. And you know who's picking up where he left off? Me. That's what I'm saying. I was like, I just listened to John Archibald Wheeler and said, we are a bit. You know what he said, though? He was uncomfortable about it because he's like, whose bit, right? Basically, who's it, right? Who's the bit? And what I am telling y'all is using his considerations, using quantum mechanics, using particle physics, using math, yes, which includes algebra and all these imaginary numbers, unordinary numbers, ordinary number, whatever. All these quirky number type things. Basically, all these types of numbers are just keeping up with the particles that are being created, which is keeping up with the mechanics and the engineering of it, which is keeping up with the geometric reality of it. That's what I said. This is the this is the electromagnetism. This is the electromagnetic drive of our current universe, our current space-time. I'm saying, yes, we can break into higher space-times if we want. Yes, we can do that. Yes, we can create super realities if we wanted to. Yes, we can do this, that, and the other. We need only try. You know, as Kennedy said, we don't do these things because they are easy. We do them because they are hard. You know, and I gotta agree. This is pretty hard. It's a fine line to walk. It's like a tightrope. Let me put it like that. Okay. It says, microlensing. We haven't observed enough of these stellar remains to create an observed map of their overall location. But a recent study in monthly notices of World Astronomical Society has modeled where we might find them. They looked at the distribution of the stars in our current galaxy and simulated how stellar remains might be tugged and deflected by stellar interactions. Right? Since these graveyard stars are typically older than the current stars in the galaxy, they have had more time to move to new orbital paths. Exactly. This is what aging is. And you can cross-confirm that with elements. If you keep smashing things in the Large Hadron Collider, then you're going to see new things. You're just simply using more energy to make more energy, to make more energy, to make more energy, to make more energy. I said, okay, well, you're using Newtonian physics. I'm saying, how about you start using quantum physics now? Because that's more efficient than the Large Hadron Collider. I'm saying you can keep doing that. That wasn't a bad idea. But you can also use quantum mechanics now. I'm saying, I think Newtonian physics has kind of reached its limit, unless you add another law to it, okay? That's what I'm saying. That's how you graduate theories into laws. That's what we've been doing. That's a scientific law is a scientific theory that has been more than proven several times, so much so that it deserves a new law now. Because it's defining, you know how people are like, oh, definitions change, or they don't change, and it's like, yes, they do, but they don't at the same time. You know how that's paradoxically true? It's because definitions have added definitions under them. So it's like, this word means this, and it says, 1, it can mean this. 2, it could mean this. 3, it could mean, that's what I'm saying. You have one word and you just keep stacking complexity. If you get bored and you're like, oh, it's not just a noun anymore, it's a pronoun, you know? And if it's not a pronoun, then it's an adjective. And if it's not an adjective anymore, then it's an adverb. And it's like, and you keep, it's an adverb. I'm saying it's still a noun. It's still all those other things, but it's also an adverb now. And it's like an adverb. 1, it means this. 2, it means this. That's what I'm saying. You can keep categorizing, you can keep adding new chapters, if you will, to words. Anyways, I don't know. I keep going on tangents. Let me read the rest of this. It says, they looked at the distribution of stars and our current galaxy and simulated how the stellar remains might be tied to blah, blah. Yeah, I reread that. Had more, yeah. Oh, yeah, that's what I was trying to say about the radio stuff, about the radio waves. And I was going to say, like the Large Hadron Collider, all these elements that you keep discovering, all these particles with mass and, you know, atomic mass and all this stuff, right? I'm saying, well, think about where atomic mass comes from, first of all. Second of all, basically, you can keep creating smaller and more like undetectable particles, and it's just going to basically, the half-life is basically going to be the half-life. You're just basically seeing further and further back into the universe. It's radioactive decay. That's what a half-life is, right? And you can look at these radioactive elements. Basically, these elements were created from stars. They were forged from stars. But now we're basically doing what stars are doing. It's just we're not able to maintain it for as long. And I'm saying, if you just look at radio technologies, then you can. If you look at electromagnetism, which is ultraviolet rays, and you apply that to gamma, then you can. If you apply that to thermodynamics, then you can. You can mimic nuclear dynamics, essentially. This is how you can have nuclear fusion. That's why it was always 20 years away, because you had to play the game correctly. And the game was to realize that resistance is just magnetism. The fabric of the universe has magnetism built into it. Okay? That's what I was saying about age. When it says they have had more time to move to new orbital paths, I'm saying time is quote-unquote an illusion. You have to deduce the tachyon particle to understand how that's possible. And I'm saying, how do you cross-confirm the existence that or how do you cross-confirm the fact that time has passed? Radioactive decay, half-life. So all you have to look at is what vacuum decay might entail, and then you can figure out what's going to happen, right? Okay. Galactic underworld, top-down, side-on. Distribution. As you might expect, the remains statistically experience a kind of blurring effect in their positions. Yeah. That's why I said in lieu of being able to refresh rate faster, in lieu of having faster or higher processing for more frames per second, more snapshots per second, more frame blocks per second. In lieu of being able to do that, you create a blur. And that is what string theory is. So basically the simulation the quote-unquote simulation that we're in can't process all this. So it just uses string theory. Okay? It literally can't process all this. So it's just going to use string theory to process reality as we observe it, right? That's why I said that's what a chromosome is. They correctly built the simulation to such a way that it could create life and teach itself. And I'm saying, you know who created this quote-unquote simulation? Hint, his name starts with G. Okay, and that's what I'm saying. Exactly. Okay. Anyways. People may not see it, but I'm moving my hands around. And I'm making like okay, we're on the same page kind of hand gesture. But, obviously the people listening to the video cannot see that visual. That's why I'm saying there's a disconnect between us talking, because it can only carry so much information. So what I'm trying to say is I want to create a language that can carry the information of the gesture I'm making, possibly. So by me even talking and not even having to make the gesture, you can understand what gesture I'm making. I said this is the precursor to telepathy, which is a big game of telephone, guys. That's all we've been playing on this planet Earth. It's like, I heard it from someone who heard it from someone who did blah, 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 blah. I'm like, okay, let's get past all that. Let's delve deeper into radio, so we can actually practice telephone technology. Did you even understand what Thomas Edison did at all? I'm saying what we have to understand here is perhaps Thomas Edison and Nikola Tesla could work together. It's the light bulb moment, but light bulb moment times 2. Understand? I said this could be like the second enlightenment period. Anyways, I've said all that stuff in the past already. But the team found one asteroid, quite surprising. About a third of these old disks are being ejected from the galaxy, and their model, a third of the stars, have experienced a close stellar encounter that has given them such a speed boost they will eventually escape gravitational pull of the Milky Way. Put another way, the ghosts are leaving the graveyard. Oh, ain't that symbolic? This means that over time the Milky Way is evaporating or losing mass, which is unexpected. We know that small clusters of stars, such as globular clusters, can evaporate, but the Milky Way is much more massive. So you would think long-term evaporation would be minimal. Another aspect of the model that was surprising is that these stellar remains are fairly evenly distributed throughout the Milky Way. Most stars should have a stellar remnant within 100 light years of them. For the Sun, the most likely distance of the closest stellar remnant is about 65 light years. So we could have a celestial ghost in our backyard and not even know it. I think you do, is what I'm saying. It's probably a radio star. You're probably radio blind to it, though. In fact, you could theoretically have like an ethereal anti-Earth like right up on your face, and you wouldn't even know it because you can't see that. But it could be like so gravitationally weak that it just doesn't do much. You know, instead of the event horizon being this superheated plasma, it could be such a light event horizon that it could its ring system could be a rainbow. But it doesn't actually have anything else that you can see, just a rainbow outline, perhaps a double rainbow outline or a triple rainbow outline. I don't know. Anyways, just a suggestion. Okay. It says, as more sky survey observatories come online, such as Rubin Observatory, we are likely to catch microlensing events and discover where these stellar remains actually are. Then we will finally be able to see the galactic world all around us. Yes. Essentially, yes. So you already saw brown dwarfs, right? Which were very, very hard to see. I said brown was the color chocolate. It was cocoa beans. It was not of the rainbow. It was very hard to see. Brown was like one of these last. It's not even on most of your gradients. You have to get mahogany just to get to brown. You have to like have a weird yellow-ish just to get to brown. I was like, okay, use gamma to adjust your dark red and kind of make it into a brown, right? Thereby you can get like a light brown, like a kind of, you can take sand, like a sandy yellow color, and just darken it until you get like a sort of a light brown to mess with, and then from there you can use gamma again to darken it actually, or have contrast actually. That's what I'm saying. Contrast is important. I said basically this is why quote unquote Photoshop is important, because photoreceptors are important here. So you can see brown. I said my eyes are like a chestnut brown. They're like really dark brown. So I can perhaps see geodesics. Okay, let me put it that way. I was like, have we really perceived any other color star out there? I mean, our own yellow dwarf star. What is it? G2V type is what Sol, the sun is. And it's in the G category. Really, our star is green. We just can't perceive it as such for reasons I will leave up to your imagination. Okay? Okay. Hey, we can use technology as a crutch to see this stuff. That's all I'm telling you guys. As I remember. Anyways, this video has gone on quite a bit, so I'll leave it there.